Technology presents educational satellite television programs.
Hello, teacher. Hello, students. Welcome to today's lesson on acid-base indicators. I am sure you remember that we began learning about this topic in our last lesson. We learned that acid-base indicators are weak organic acids or weak organic bases that indicate whether a solution is acidic, basic, or neutral. We learned that if indicators are in a medium that is acidic enough, they will shift to the left, according to Le Chatelier's principle. We also learned that if indicators are in a medium that is basic enough, they will shift to the right. A shift in either direction causes a color change to the conjugate base. In today's lesson, we will define acid-base titration, as well as endpoint and equivalence point. We will explain titration procedures and processes, and we will talk about acid-base titrations and show equivalence and endpoints using suitable indicators. Let us begin. Titration is a technique in which a solution of known concentration is used to determine the concentration of an unknown solution. It is typically performed by adding the titrant from a burette into a known amount of analyte. The titrant is the substance that is known, while the analyte is the unknown solution. This process is done until the neutralization reaction is finished. When the acid has completely reacted with the base, or it has been completely neutralized by it, the equivalence point of titration has been reached. If the amount of titrant being added is known, it allows for the determination of the concentration of the unknown solution. Indicators are often used to show when the reaction is complete, or to indicate the end point. The end point of titration is the pH at which the indicator changes color. A graph of pH can be used to show the amount of titrant that has been added to a solution. These graphs are known as titration curves. You will learn more about these in a later lesson. Students, let us do an activity to review what we have learned so far about titration. In a moment, you will see several incomplete sentences. Please complete the sentences to the best of your ability, and I will see you in a few minutes.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. How did you do on this activity? Let us complete the sentences together. The end point of titration is the pH at which the indicator changes color. Titration is a technique in which a solution of known concentration is used to determine the concentration of an unknown solution. Indicators are often used to show when the reaction is complete or to indicate the end point. Titration is typically performed by adding the titrant from a burette to a known amount of analyte. Were you able to correctly complete each sentence? If so, you have done a great job. If not, please review your notes at the end of this lesson. Let us continue by going through the techniques of titration. In this image, a precisely measured amount of hydrochloric acid has been expelled from a pipette into an amount of water in a flask. Then, as you can see, several drops of phenolphthalein indicator solution are added. The solution remains colorless. The solution is acidic. In this image, an aqueous solution of sodium hydroxide is slowly added to the flask from a burette. Until the hydrochloric acid has been neutralized, the hydrochloric acid is in excess and the sodium hydroxide is the limiting reactant. The solution remains colorless, which indicates that it is still acidic. When the acid has been completely neutralized, the solution has reached its equivalence point. The hydrochloric acid and the sodium hydroxide are in stoichiometric proportions. If another drop of sodium hydroxide is added beyond this point, the solution becomes slightly basic and, as you can see, it turns a light pink color. Here, the titration process is stopped and the volume of the solution that was delivered from the burette is recorded. In order to perform titration successfully, an indicator that changes color at the equivalence point must be used. Students, from the process we just described, how can the volume of sodium hydroxide at the end point be determined? What is the normality of hydrochloric acid at the end point? Also, what is the similarity and difference between equivalence point and end point level after reaching the end point?
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, everyone. I hope you did not find these questions to be too difficult. The volume of sodium hydroxide at the end point can be determined from the reading on the burette. The volume added is equal to the initial volume minus the final volume. The normality can be calculated by using the relation. Thus, the normality of the acid solution times the volume of the acid solution is equal to the normality of the base solution times the volume of the base solution. The equivalence point is the point where the equivalent quantities of an acid and base are reacted. The end point is the point where the indicator changes color in a titration. Theoretically, these 2 points should occur around the same time during acid-base titration. However, errors can happen depending on which type of indicator is used. This is because, as we have learned, different indicators have different pH ranges of color change. In today's lesson, we learned about acid-base titration. Titration is a technique in which a solution of known concentration is used to determine the concentration of an unknown solution and vice versa. Acid-base titration involves a known amount of acid which is used to determine the concentration of an unknown basic solution. This brings us to the end of our lesson. Until next time, thank you, teacher. Thank you, students.